Good afternoon and welcome to this afternoon's webcast. I'm Darcy Wadle with Electude, and I'm going to be showing you the engine management simulator here today. So looking forward to presenting this tool. This is kind of one of Electude's crowning jewels, but obviously there's some things about the engine simulator that you need to be aware of, and how to use it and how to access the tools and build faults of your own. So this is being recorded, and I'll pause every now and then to allow you to ask questions. Just want to make sure. I think I am definitely sharing my screen here. Yes, I am. So let's go ahead without delay and we'll get started here. I'm going to go in as the teacher. And of course, my site has probably a few more products than what maybe some of your sites have, but these would be a lot of our partner products here. So first, we'll describe, where to find these engine management simulations. So if you're an AST or MAST customer, if you have access to this folder, there is a predefined course here that has some advanced simulator faults kind of cherry picked for your viewing pleasure there. So we have a course here put together, Basic, Advanced, and Specialist, and this would give you a good start where you can use these courses directly, or you could copy these courses, make them your own, and then add your own faults to it. So if you're an MLR customer, you don't have this folder, but if you subscribe to AST and MAST, you have this course here for the engine management simulator faults. There's also a new case study course here as well. This is going to be a new module that uses elements of the simulator. This is also available. These we'll probably touch on these toward the end of the webcast, but just wanted to draw your attention that we got a new course here called Case Studies. And right now we just have one case study that was released, but these will continue to come out through the next few months. So let's jump in and learn how to use this simulator. So you got this course here where you can find them. Also, if you go to the Modules tab, and then you go to ASC content areas, there is a listing here called Electude Simulator. So if we click to open this up, either down below here from these folders or over here to the right, you can navigate these folders and look at Basic and Advanced and Specialist simulator faults. There's also a perfectly good running vehicle here. This is called Electude Engine Management Simulator. And maybe we'll open this one up first. And so like if you're an instructor and you just want to demonstrate to your students that the tools inside the simulator, or you want to use this during maybe a Zoom call or something like that to demonstrate a diagnostic procedure, you can use this lesson for a lot of different things. So if we start this up, I'm just going to kind of give you maybe a basic walkthrough of this first, and then we'll look at some of the faults, and then I'll show you how to construct your own faults. So when a student or teacher opens up a simulator, you're going to get a work order over here to the left-hand side. This one obviously is a no fault, so it just kind of explains that to you here. You can print the work order out, and then the X here would close it. If you're on your computer and you have a mouse or a trackpad where you can control a cursor, you can use either your mouse wheel or to zoom in and out. If you're operating the simulator, however, on a mobile device such as an iPad or a tablet, you have to use the slider over here to the far right, or you can use the plus and minus buttons to zoom in and out. But don't use your pinch and spread on the screen. It just doesn't work well on a tablet, so make sure you use these buttons over here to the right. I prefer using a computer with the mouse in my hand, just as more precise. So you can zoom in and out on this car with your mouse wheel. You have a speaker control over here also to the far right where you can turn the volume up and down. And then over here to the left is your tools. So we have an instrument panel, multimeter, a lab scope, 2-channel lab scope. You have your diagnostic tester. So here's basically your scan tool. And we'll take a look at that here in a bit. And that's also where your supporting documentation is also found, like your specs for your sensors and things like that are also found in there. We've got a nice little breakout box here as well that you can connect and do your pinout tests on the engine management control unit there. A fuel pressure gauge. I'm getting too many tools out here. A jump starter box where you can put give the battery more voltage. You have a wiring diagram that can be also printed out. So for students that are working from home and they want to have save screen real estate, you can print this out, and then students can use their crayons or whatever to mark up the wiring diagram. So that's nice to have that. And then we've got the work order, obviously, and then the invoice. So as students are working on this, as they replace parts and components, and it will track their time and their diagnostic steps, and that'll be reflected on the invoice. We charge $1 a minute for diagnostic time. There's also a good number of video tutorials in here. So in addition to the training today, you can refer to these video tutorials. And then, of course, a help button and a full screen option. So we'll kind of go through here in reverse order. Let's look at this wiring diagram here just real briefly. And so you can drag this corner to make it real big or small. It is printable, like I mentioned earlier. The other nice feature about I would call this the paper wiring diagram, is the students can hover their mouse over a component and it'll tell them what that part is. So it's a nice tool as well for students to learn symbols and things like that. So here we got canister purge valve, EGR valve, injectors, etc. Your pins here in the control unit here in the center, these pin numbers match the breakout box. So if we look at pin 25 and we go over here to the wiring diagram, pin 25 goes to the signal to it's the signal coming out of the ECU to trigger the number 4 ignition coil. So you can take those measurements here with your breakout box. So that's the wiring diagram, that's the breakout box. To put a tool away, you just simply open up the menu and click on the item again and it closes it back up. So the fuel pressure gauge, pretty self-explanatory, I think. It is in kPa. There is no English unit measurement, so everything is in the metric system, but I find that's usually not too much of a challenge for students. Your diagnostic scan tool, let's take a look at this here briefly. Again, you can drag this corner to make it big or small. There are some, we do have to have the key on, just like any other scan tool that has to have power going to it. So you will have to turn the key to run to operate this thing. So we start identify the vehicle. So it boots up just like any diagnostic system would. We got a VIN number for the vehicle that we're working on. We have our systems. Now, although we have airbags, audio, and climate control listed here as kind of a realistic view of what you'd often find in a scan tool, this is only an engine management simulator, so the only option you can actually click on is engine management. And then from here, you can look at live data. So we can check what items we want to look at here. So if I want to take a look at engine RPM, mass airflow sensor, and maybe accelerator position sensor, I can display those units on the screen. So it does have a nice graphing mode here. You've got your units, your min and your max value, and your actual value, and then your min and your max. So when we start this car up and we stroke the throttle, you'll see how the graphing meter responds. So you have that ability where you can graph things out. So here's our actual value and then our min and our max over here. So that's your live data. You have, you can read fault codes. So we've got memory and actual or active, however you want to refer to those. So here we have a memory code stored in the system, crankshaft sensor circuit range performance. If you click on an item, it will open up the freeze frame data. So you can look at what the operating conditions were when the code's set. So just like a real scan tool, you can take a look at that. To clear a fault code, down here at the bottom, you can delete fault codes and clear them out. One thing that's unique about a simulator that's maybe different than an actual car is that codes are set immediately in the system, so you don't have to wait for drive cycles and things like that. So for example, if I unplug this intake or this coolant temperature sensor, immediately it's going to trigger a code. And you'll see that we have an actual code here. So any kind of drive cycle, that sort of thing is going to be hastened or it's accelerated. So you don't have to wait for drive cycles to be performed for codes to set. When and you'll see also here on the dashboard that the check engine light comes on. If I plug this back in, again, things are going to be accelerated a little bit, and you'll see that the light goes out. Obviously, a real car wouldn't behave in quite that way. The check engine light would remain on. But here again, in a simulated environment, this have to tell your students, drive cycles and things like that are accelerated. You don't have to wait for things to necessarily happen. So there is some slight differences in the way the simulator works to a real car, but you just have to remember this is a simulation, not a real car. So there we have that information there. So deleting codes. We can also go back here and we can perform an actuator test on the vehicle. So we have the ECU, and we also have the throttle control module. So if we start here, you can see I can control the throttle from here. And then over on the ECU side, we can, for most of these, you have to have the key off and the engine, key on, engine off. But I can make the fan relay come on. To hear if the fan actually responded, you can zoom in on it really close and you can actually hear it run, or you could take your voltmeter and measure your voltage drop across the fan to see if the fan is working. So you can see now we got 0 volts. Now we got 12 volts. So you can kind of test the function of the relay in this way. Same thing over here at the fuel pump. You can turn the fuel pump off and on, look at fuel pressure, or again, you can go to the back of the car where the pump is, and you could zoom in on this pump and measure the voltage drop across it, whatever you need to do there. You got you can also change the injector pulse width and do like an injector balance test with the fuel pressure gauge. You can command the canister purge valve open and basically cause the engine to run lean with either the canister purge or the EGR valve. And then, of course, you got your throttle control here as well. So a lot of nice bidirectional controls in the scan tool. That's under Actuator Test. You have vehicle programming where we can either configure the throttle control module or the ECU, where you can reprogram the computer. And then over here under information, this is where you're going to find all your vehicle specs and things like that. So if we look under block diagram, this is going to give you just a schematic view of the CAN bus system. So we have a high and a low CAN bus wires. And then the wiring between the ECU and the throttle control module. So you can measure the CAN bus voltages either here at the throttle control module. I'll show you where that's at really quick. So here's our CAN high and our CAN low. You can see the twisted pair coming in. So there's the green wire with the white stripe. That would be our CAN high wire. And here's our solid green wire, our CAN low. And then we can measure here at the ECU with our jumper box, with the breakout box. The gateway computer, it's here for, again, to show schematically a realistic looking CAN bus network. This module isn't actually identified. That's not somewhere where you can actually go on the car. We can't go underneath the dash on this vehicle and measure this resistor at the computer. So this could be the instrument panel cluster, the BCM. It's a schematic view. It's just showing that there is another module on the car where this CAN bus terminating resistor is located. But as far as physical measurements on the vehicle, those can either be made at the throttle control module or the ECU itself. So that's the block diagram. And then you have another version of what I call the paper diagram. This one here, if you hover your mouse over the component, the paper one would show you the the component name. And this one here is where you get specifications from. So if I wanted to get the specs of one of the fuel injectors, I can click on it and it tells me what the supply voltage should be, what the resistance value of that injector is, where it's physically located on the car. And then down below here you have a known good lab scope image with your time and your voltage per division settings, and then the conditions for which that pattern was taken. So this was on a hot engine idling relative to pin 2 to ground, so connected to the injector. So you have that availability where you can click on the item, and then if a student doesn't know what these items are, they can also find it down in the legend here. So if I click on fuel pump relay, shows me where on the car it's located, a pinout of the relay, and then the specifications, like here's for the relay coil, 45 ohms on that coil. So all your specs are right there, right in the scan tool. So very handy right at the student's fingertips. I'll pause here and just see if we have any questions. I forgot to mention when I started the webcast, as questions come about, you're welcome to type those in the question or chat box. So I don't see that we have any questions yet, but as those come to your mind, feel free to type those in, and we'll get to those questions as we move along here.
Darcy, you do have a question.
Oh, do I? Okay.
Can the simulator do a recording in the scan tool and the recording be saved for future playback?
No, there is some limitations of the simulator but so there's no ability to take a snapshot or anything like that. I do think you can pause the live data stream though. I thought I could be wrong on this, but yeah, there's no pause button on this or anything. There is a pause on the lab scope, but no save documents here. Another question that sometimes come up is there flow charts and things like that for the student to go through? No flow charts, and that was done intentionally. What they really want the student to do is kind of develop their own diagnostic strategy. Flow charts were developed to make technicians more productive in the shop, to help them get to the fault very, very quickly with probably minimal thought. And with the simulator though, we want students to struggle a little bit and figure out their own diagnostic strategy through studying of the wiring diagram and then looking at the specs within the service documentation. So they kind of have to figure out their own flow and their own way of working. I often suggest to teachers to use the simulation in front of your class, maybe go through 4 or 5 faults together, to teach them like a diagnostic strategy or something like that. But no flow charts or anything like that. Let's see here. Is there any other questions? Not sure why I'm not seeing the questions. I'm just seeing.
I don't know. There are none right now, Darcy.
Okay, all right. Well, thank you, Vern. All right, so let's go here, continue onward. Close out some of these things here. So let's look at the lab scope. Very nice lab scope here. So as far as hooking up your alligator lead there, your negative post, that has to be connected to the battery. So this will always be connected to the negative post of the battery. You can't connect it like on a bolt or anything like that. So it always goes here. And we'll turn this on. So you got your channel 1 and your channel 2 labeled up here at the top. Channel 1 is always on by default. So if I was to, let's just connect it here to one of these fuel injectors. And we'll start this car up. So when you hook it up to a sensor or an actuator, you're initially going to get kind of a rolling screen here. There is an easy setup for your students. They can easily just click the auto button and it'll kind of pick a voltage and a time base. And then from here, you can kind of adjust it to suit your need. So right now we're on the 20 volt per division. So every one of these boxes here is 20 volts, and then I can either zoom in, there's 10 volts, 5 volts, or I can go the other way. So you can kind of change your voltage division, and then if you want to lower your line, here's our 0 line. Right now you can see channel 1 is highlighted. I can move that 0 line up and down wherever I need to. And then just like a real lab scope, we have a trigger. So if I zoom in on this a little bit here, you can see right now that I'm on a negative slope, meaning that it's zeroing in here on the negative voltage. I can change that though, and I can change my slope to positive, for example. And now you can see it's on the rising edge. And then you can also adjust your trigger as far as the voltage level. So if I want to move it up or down, I can move it up or down. This is particularly useful if you have 2 channels that you're measuring. So if I would turn on channel 2, turn it on, and maybe I'm measuring the crank signal here as well. So right now I am triggering off of channel 1. But if I wanted to trigger off of channel 2, I can go over here to trigger, move that to channel 2, and now you can see that we kind of got a randomized pattern here. And if I want to zero that in, here again, if I get it too high, it's gonna skip across the screen. If I get it just right on that pattern, it kind of zeroes it on the screen. And then I can also move it to the right or to the left. So just like a real lab scope, you can adjust those triggers to get just what you want to look at. A very nice feature for analyzing scope patterns and that sort of thing. You do have a stop run. This memory button is kind of, you can save some things here if you want to, but it would be just for during this fault to refer back to later. It wouldn't be that those things would be saved indefinitely on the tool for other faults, but you can create screen captures and things like that. So that's the lab scope, really a nice tool. Let's look at some of these other tools here, and then we'll jump into some of the faults.
Hey, Darcy, before you move on, I got a couple questions for you.
Yeah.
One is, could you circle back and show how a work order is created?
Yes, we'll get to that in just a second.
Okay, and the second one is, question is there a simulator for the MLR level course?
The For MLR customers, the simulator is not included in your subscription package by default, although it can be added to your subscriptions. There's no course, however, like there is for AST and MAST. So if you purchase the simulator as an add-on, or if it's on your site, I know there's certain states that maybe the simulator is included with your MLR subscription. You would have to build your own course. So there are some things, if you're an MLR customer, that you would have to do on your own that maybe is already done for the AST and MAST customer. However, you're getting a lower price, so there's just a fewer, maybe just a few less features with the MLR than there is with the AST and MAST subscription.
Mm-hmm.
But I'll show you how to build a course here in just a bit. So maybe
Great.
we'll.
Thanks, Darcy.
All right. So as far as replacing parts and things like that in the simulator, all the parts are removable, replaceable. You can unplug parts. You can pin out these parts. You can check voltages either at the connector or at the component. You can measure resistance and things like that. To remove a part, you can just drag it down here, and this is your storage area down here at the bottom. So you can take parts out. The system will score students based on what they remove and what they replace. If a student removes a part that's not faulty, it will count off just a little bit. I know that in the shop sometimes we kind of even often teach to students that, hey, if you have a misfire on one cylinder, you can swap coils and see if the misfire will move. The system will dock just a little bit for that, but as a trainer, you can override that score. In regard to the relays and things like that, you have your wire colors that you can look at here as well, and then you have your relay views, and you can compare that with the scan tool for your pinouts and things like that. So by looking at the orientation of the pins together with the colors, most students should be able to identify these pins fairly easily. And of course, your fuses up here. Here again, there is two 4-pin relays. You can drag two 4-pin relays down, and you can swap their positions if you want to do kind of a quick and dirty test there. That's possible. So you got that. This here connection that goes to your throttle position sensor or your pedal position sensor underneath the dash. So we can't physically go underneath the steering wheel, but this connection here would give us access to the pedal position sensor. And then of course you got your other actuators. This would be your canister purge solenoid, your oxygen sensor, engine temperature sensor, cam sensor, crank sensor over here, etc. So let's talk about those work orders then and how to build your own. Let's do that.
And Darcy, while you're doing that, there was a follow-on question from the same guy who said they will also want to know if there's diagnostic strategies from a manual for students to follow like they do real world. So walk through the creation of the work order and then talk about how they get their strategies.
Their diagnostic stuff. Yeah. Okay. All right. So let's start by showing you that there are over 50 different faults that are already created that you can grab and assign these to your students or arrange these into a course. So there's basic simulator faults, there's advanced faults, and then there's specialist. There's about 50 faults in all, but then what makes them either less or more difficult is the clues that are in the work order or what tools that they give the learner to use. So for example, we're in basic wire defective resistance between cooling fan, fuse, and fan relay. So here it's a resistance problem. You, the teacher, you see where the fault is actually located. So it's a bad wire between the fuse and the relay. This is what the student is going to read. They don't see this wiring diagram. they don't see this title. They just see Electude Simulator Engine Management. That's what the only thing they see. They get the work order, engine overheats, check power supply from the fan relay and repair as needed. Be sure to document findings. So already in the basic fault, we're kind of giving them a clue it's a problem with the fan relay circuit. So those are your basic faults. They get a little bit of a clue in the work order description. The advanced faults, if I try to find the same one here, well, I probably won't easily find the same one, but here we got a bad relay. Engine overheats, repair as needed. So no clues there as to what's going on, as far as, dealing with the fan relay or anything like that. So the advanced faults are more cryptic, where they got to figure things out. The specialist faults, they often will have the student use a tool they're not very familiar with. So here, for example, here's our fault, a problem with the coil. Customer says engine hesitates, diagnose and repair as needed. Let's look at another one here. Check engine light comes on. So, it's just very, very, very oftentimes the work orders don't provide much information, which makes it more of a challenge. So, and then if you want to build your own fault, you can build your own inside these folders. So if I wanted to create my own advanced fault, I can open up this folder, and then here's the list of faults that are available to me. If I want to build one of my own, I click the plus. And so when you click the plus in this folder, any of these folders for that matter, you're entering the DIY area or the do-it-yourself tool. So by default, when you click the plus, what's going to be shown here in this line is lesson. And this would allow you to build your own Electude lesson in the platform. But we're not wanting to build a lesson at this point. We could also build a test, a digital lab task. We can upload a file into that folder or put a web link out there. What we want to do here is build our own simulation. So you click on simulation, and then you have to title it. You have to title it before you can actually select a fault, which seems a little bit backwards in a way. So, maybe ideally it'd be nice to select the fault first, but we have to create the structure first. So you have to kind of think like a computer here. So we got to create the file name. So I'm just going to call this fault 246 for now. I'll rename it once I select the fault, and we click add. So once you create the fault 246 up here, now we can select from any one of those 50 different faults available. So if I click this one, wire faulty, resistance between fuel pump and fuel pump relay. So that's my fault that I selected. And if I hit OK to save that, if it's a wiring issue, you're going to get a wiring diagram where you can actually physically see where the resistance lies. So here it's a bad wire between the K3 relay and the fuel pump. And now I can write the work order. If I want to see what this vehicle runs like before I do the work order, I can start this up and view how it runs. Notice that if I start this up without writing a work order, there is no work order. So it is important that if you're building your own faults that you do fill that out. Otherwise, your students won't know what to do with this car. So, but you can start the car up, see if it runs, if it stalls, or kind of its behavior then before you write this work order. So if I want to write here, engine cranks but does not run, repair as needed. Now, if I wanted them just to maybe provide an estimate or something like that, you can also turn off the ability to replace parts or wires. So you can make that more difficult or less challenging by what tools and features that you allow the students to perform. So you can turn some of those things off. when you create your own fault, you can have it either automatically evaluated or manually evaluated by the teacher. So if you have it set for auto evaluate, it will deduct if they replace a part that's not faulty, if they remove a part that doesn't need to be removed, etc. So there is some things to be mindful of on the automatic grading, but I do recommend leaving it on. I think it's students typically like to get instant feedback as to how they're doing. So once you hit OK, that saves everything, and this fault, besides the title here, is ready to go. So I will change the title now. I'm going to click the pencil, and I'm going to call this crank no start. And if you want to put a number on that or whatever, you don't have to, but I'm just going to call it crank no start. So now it exists in this advanced folder with all the others. There you see it's up there at the top. So if I want to now assign this to my students, let's do that. We're going to go over here with students. I'm going to just create a group. Call this demo class, hit add. And now I'm going to put a student in there. So let's put, let's find a student that we can put in that group, just like that. And now we're going to assign that fault. So we're going to go back over here to modules, and there's that crank no start. So I'm going to assign that to my demo class. So crank no start. So now let's see what that looks like then for the student. So we're going to log out here as a trainer, go in as a student. Content, a demo class, other modules. Because I assigned it as a module, not a course. Remember, when you assign content as a module, everything gets thrown into this folder. So this demo class doesn't have a course folder, they just have other modules. Open that up, and notice what they see: Electude engine management, Electude simulator engine management. No clues as to what that fault is. So if you're also using this tool like during a Zoom session with your class, you don't want to have the name of the fault show up in the upper corner. So I always recommend that if you want to go through a diagnostic scenario with your students, put yourself in there as a student, assign it. You know what the fault is, but when you open this up in front of your class, the answer isn't staring him in the face up here in this red banner. See, if I would have opened this from the teacher login, the answer would be in the title up here at the top, and we don't want that. So here again, if you're going to be teaching from a distance this fall, find the fault you want, assign it to a student group, and then log in as a student. Now there's no clues as to what this is. Here's the work order write-up that we just wrote. Engine cranks but does not run, diagnose, repair as needed. Now, from the student's perspective, they're being evaluated now on every click that they make. Now, whether or not they check for codes first, or they duplicate the concern first, or they open up a wiring diagram, none of that is evaluated or matters. What matters here is how quickly can they diagnose the fault and how accurately can they diagnose the fault. And when it comes to flowcharts and things like that and diagnostic helps, we don't provide them any of those tools. That's important for maybe when they're working in the shop for real. But hey, this is a simulator designed for practice and learning, and they intentionally neglected. They didn't neglect to put those things in there. They intentionally left those things out because they want the learner to kind of come up with their own diagnostic strategies through careful study of the wiring diagram, what they're seeing the car do, what they're able to glean through looking at scan data, etc. So if I'm kind of playing the role of the student here now, what would I do? Well, and here again, this is why I think it's important for you as a trainer, go through a few faults and you teach them a strategy. So if I was a teacher, I would probably tell my students, we'll always duplicate the concern first. So we're going to grab the instrument panel here and we'll crank away and see if this thing starts or runs. And while they're cranking this thing here, you can hear the engine running. If you zoom in, it's almost like getting a stethoscope out, and you can see that the engine's there. It actually started and run a little bit, but when I accelerate, it just kind of falls out and stalls. But we can see that it has RPM. We can see that the check engine light comes on. That you can hear the main relay clicking on and off. So there's things that you can glean information from just through listening. And then we can also grab the diagnostic tester here now and check for trouble codes. So we've got oxygen sensor circuit, no activity, and then system 2 lean. So we got a problem here with the vehicle running 2 lean. So what would be the next logical thing to do? Maybe to maybe check, well, what's our fuel pressure? So if we power this up, looks like we got about maybe 175 kPa in that ballpark. Well, how do we know what that should be? What is our specs? So we can go over here in our manual, our diagnostic tester, systems, engine management, information. Remember at the beginning of the webcast, I said all your specs are in this wiring diagram. I can click on the fuel pump, and then here is my supply voltage, my resistance value, fuel pressure 200 kPa. So you can see we're well under spec there. And of course, when I accelerate, the pressure drops off very rapidly. So we definitely got an issue here with fuel pressure dropping off. So this is a returnless system. Doesn't have a return system. So what are our possibilities? Well, we can go back here to the pump. So if we got low fuel pressure, we either don't have a good supply voltage, or maybe the internal regulator is malfunctioning, whatever. So the next step, what I would do would obviously probably check to see what our voltage drop is across that pump. So we can grab our multimeter here. We can back probe our connections. Turn this to 20 volts, and let's see what our, and you can actually, this probably isn't coming through the webcast very well because of the way where my speakers are pointed and my microphone, but I can barely hear that pump running. It doesn't sound like it's running very quickly or very fast. And we only got about just under 5 volts being dropped across the pump. So we're losing voltage here. So is it on the power side or the ground side? That would be the next thing for the students to figure out. So, well, let's check, see what our voltage drop here is on the, what our voltage is available on the power side. So using our really nice flex leads here, we'll see what our supply voltage is. And it's only 4 volts coming in at the pump. We can check and see what our voltage value loss is here on the power side, and you can see, look there, we're losing 9 volts on the power side. So I got this on the positive side, I got this over here on the positive side. So somewhere on this positive connection, we're losing 9 volts of electricity through the power side. So yeah, we got a voltage drop issue. So now we're going to grab the old wiring diagram and see, well, where can that voltage loss be occurring? So with one lead here on one and the other on the positive post, I know that I'm losing some voltage between this point here and here. So where can I measure the voltage loss? I can either at this splice or the pin 3 of the K3 relay. So that would be our next place to go. So there's our K3, and we want to measure the voltage at pin 3. That's the orange wire, so it's right there. So if I measure the voltage here, and so if I see 9 volts here, I know that's my problem. And sure enough, we're losing 9 volts between the positive wire and somewhere here in pin 3. Now it could be a problem, not pin 3, this wire here, I guess. Okay, so we could measure and see what voltage we got at pin 2. Just check that out. That's the purple and red wire. So we're measuring there. So we want to check our voltage level. Let's see. Just make sure we have 12 volts available. I can unplug that. Put that on ground. So there is 13 volts available, but we're losing that voltage between there. So more testing could be done. Let's say we figure that the problem is in this wire. So if I want to replace this wire, I go back to the wiring diagram and I can ask for a new wire. You left click on it and then you replace it. Once you replace it, it strings a new wire on the car and it charges parts out on the invoice. So now if I go back here and I measure that voltage on the positive side, that should be relatively low now if we did our work right. There you can see there's no voltage being dropped there now at all. Or 6/6 of or 600ths or 60 millivolts, which is acceptable. So everybody think we found the problem. We look at our fuel pressure. It's now 200 kPa, so it's where it should be. There's still codes in the scan tool and things like that, but we essentially fixed the problem by replacing that wire. And then you got your work order. Let's look at the invoice. So we spent, we did OB2 scan. We got our parts charged out here, troubleshooting time 10 minutes, additional labor 30. So we spent $78 so far. So once the student kind of completes the repair, they do need to make sure that they clear the codes on the car. It will count off if you don't clear codes. So we got to follow codes, clear the codes out, put our tools away. It will count out for that as well. Can't leave any tools sitting on the battery or anything like that. And then once the student feels like they fixed the car, they get the work order out. I'm not going to take time to fill this out because I want to get to questions, but they fill this work order out. And now if they exit at this point, the fault is still active. Meaning they can close this down, re-enter it, and pick up where they left off. But once they fill this out, they verified the failure and all that. Once they click this button here and they turn the vehicle to customer, this activity ends and they can no longer go back and replace parts or things like that. This activity ends at this point. The failure is resolved. And now the teacher is able to go back and review this. So we got a perfect score. That's so the student gets immediate feedback. So what's the teacher see? I'm going to pause here in just a moment to see what questions we have, but I want to show you this one point here at first. So here's my demo class. Here's the failure. Here's my student. Your next click will be on the failure itself, and then your student. You'd have a long list of students here that was probably working on that failure. And now you click on the student name. You'll see their work order write-up. You'll see their invoice, how much money they spent, and most importantly, here's every single diagnostic step that the student took to resolve that failure. So if you saw up here at the top that they were replacing parts or components, that's not a good thing. But the first thing this student did is they opened the diagnostic tester. Then they opened the fuel pressure gauge. Then they got the meter out. So you can see even what pin numbers they tested, etc. All this is recorded for you, the trainer. So if you saw activity here that you thought maybe the student wasn't doing this diagnostic for real, you can adjust the score accordingly based on what you feel the performance should be. So if you thought, well, you know what, I don't think the student deserved 100, we're going to give them a 95. You can adjust that score because we didn't do a very good work order write-up for whatever reason. So very nice that you can adjust that score accordingly. So I've been talking for quite a bit. Let's see what kind of questions we have here. So
We got a few, Darcy. Can you see them now?
I can see them. Let's see here.
The one by Robert Morris is the first one that you haven't responded to.
Okay, all right. So are the pinpoint tests students can follow per fault? All the faults, students can do the same pinpoint tests as long as you provide them access to those tools. So meaning that the simulator is fully functional in every way. You can run any test. You're not going to be stopped. There's not anything you can't do on that simulator fault. They might spend an hour or two diagnosing a problem, and that's fine. But they're not going to be guided. There's not going to be anything that's like turned off that they can't test. They're going to be able to test all the components, all the wires. The only thing that you can control is whether or not they have access to certain tools, but they're going to have access to all the features. Nothing's turned off as far as what they can test. The next question here, can you select the faults that the simulator has correct? In other words, can you put in your own fault, such as removing a fuse, installing it in open in the fuse panel? So that's a good question. Can you create faults in the simulator? No. You're pretty much limited to the faults that you see here, these 50 faults. But the fun part is, how you can manipulate that through what you write in the repair order. Most of these faults here are pretty good. We've got, open wires, shorted wires, high resistance wires, components, etc. I think you've got probably more than enough faults here for, for your students for probably 2 or 3 years worth of training. So I don't really feel it's too much of a hindrance that you can't put your own faults in there. You can take any one of these, and create your own version by what you write in this repair order. And I think that there is good enough in my opinion. Next question. So in the case, we can log in as a student with our teacher login info, and we must place in a class, or is it automatic? Okay, yeah, let's talk about that. Just strategies for using it in front of your students. So right now I'm in as a teacher, and you can see that the fault here is in the description. So if I start this up in front of my students, that's not going to be very much fun. Because the answer is in the text here. They're going to say, well, oh yeah, I think the computer's defective. There's probably, a problem with the fan control. So if you're using this as an example in front of your class, don't go in from the teacher view, and you will have to create yourself as a student in the program. So create a demo class for yourself. Here's the fault I want to assign. I'm just going to drag that fault over. There it is. And now I'm going to log in as the student. So put yourself in your own site as a demo student. Even create a demo class. That way it doesn't maybe affect any other results for the class or something like that. And then log in as a student. So if you're teaching from a distance, here it is. Engine overheats, confirm the ECU is the problem. But see, there's no description. So when you start this up, there's the fault is hidden from the student view. So that's how I would answer that. Next question, can you reset the simulation for a student if he wants to redo the task? Absolutely. So I'm logged in here right now as a student. You can see here's the previous one that we did. I can start this up, but it's a fixed car. I've already completed the work order. This car starts and it runs perfect. If I wanted my students to redo that same fault again. Very easily done. Just log in as a teacher. Here's the crank no start. Now, and so imagine having 20 students here, not just the one. But here's the fault that we did earlier. We spent 10 minutes and 32 seconds. If I wish for my student to redo this fault, I just simply click the X. Are you sure you want to delete the results? When you click delete, everything is reset. The student can go back and diagnose that fault again. And the other nice thing about, because it's a self-made fault, if you want that student to do it again, but maybe make them think it's maybe a different fault, you can always go back here to all new. Here's our crank no start. You can change this work order description up a little bit. So if I wanted to change this a little bit, maybe I just want to do here diagnose and provide estimate only. So here I'm going to turn off the ability to replace wires and parts. I'm not going to put an invoice on there. I just want them to do a work order write-up or something like that. You can do whatever you want there. Change that up a little bit. Maybe engine starts and stalls. So even though it's the same fault, I've changed things up a little bit. So if you think about those 50 faults and then the ability to where you can adjust this work order, you've almost got, infinite possibilities, or you could create, 5 or 6 versions of each fault. So that's quite a few faults that you can throw at your students. And that's how I would address that. The biggest issue I have encountered is students unplugging the wrong component and setting codes. This confuses them. Sure. So yeah, absolutely. And there again, you could probably control this a little bit by explaining this to your students. I think it is good for you, the teacher, to run through a few faults of your own. Obviously, if they unplug a component or a sensor while the key is on, it will set codes for those, and or false codes in a way. So if they're going to unplug something to check resistance or to check voltages, make sure that they do so without the engine running. That helps a little bit. They can also clear the codes every so often if they need to, but yes, it will set a code if they have the engine running and they unplug the camshaft sensor, for example. It'll stay running, but it definitely will set a code for that. Some other things just to tell your students, I will show you this real quick. This is often causes confusion for students. The power wires coming into the computer. Pin 26 here, this is our main power feed off of fuse F6. But if we look over here at the K2 relay, K3, K4, you got what looks to be power wires coming in to the ECU on pin 1, on pin 4, on pin 7 and 6. These are not power feed wires. These are signal wires. So if I was to tell you there's a little resistor inside here with a little voltmeter across it, the computer's monitoring the voltage drop across this little resistor. If it doesn't see a voltage drop when the key is on, then it knows that there's a problem either with the main relay or this fuse. There's an open, it'll set basically an open circuit for this fuse or this relay. So these are signal wires. Same thing here. There's a little resistor in the computer, and it's monitoring the voltage drop across that. If it doesn't see a voltage drop, then it knows that either this fuse or this relay isn't working. So these are signal wires, not power wires going into the ECU. Let's see. The next question. How do I download? Have to maybe be more specific on that. So Kenneth Berkeley, you're asking, how do I download? Is it download the results? Is that maybe what we're talking about? We'll come back to that one. Do we have to pay for Electude? Do we have to pay for Electude to get the simulator? No, you don't have to pay for Electude. There is a free game site. This is not the training version. This is a game version. But you know, if you're an MLR school and you can't afford the simulator, or if it wasn't included in your package, you can direct students to this website, simulator.electude.com. And even if you do have a paid subscription to the simulator, you can train your students up on how to do diagnostics and then turn them loose on this game version, and they can compete with other students from all around the world. So there's tens of thousands of people playing this game every week. Here are the top 5 people. It doesn't show where they're at in the world, but by the writing here, I would say this is probably somewhere in Asia somewhere. Probably could be in Russia or something like that. Who knows? But they can sign up for this, and they'll get random faults thrown at them. And then you, the teacher, you can also sign up for this, and then you can go through a diagnostic scenario in front of your class, where you can simply, without even signing up, click that button, and then you've got a perfectly good running vehicle here that you could then demonstrate how to use a lab scope or a scan tool. So you don't even have to have an Electude site to use this tool. So that's just simulator.electude.com. So there's no results that you can glean from your students. So it's not a replacement for the training version, but if you don't have this on your site or you can't afford it, it is at least something that you can have access to in a Zoom meeting or something like that, where you can demonstrate how to use a lab scope or how to test a component or something like that. So it's kind of Electude's free gift to the world. So whether you use it in your own classroom or you just turn your students loose on it and say, go out there and play and compete, see if you can get your name on the leaderboard, that would be awesome. Let's see here. Can you do a webinar on steering suspension? Yes, I'm sure we can do additional webinars there is an alignment, kind of a simulator in Electude where students can perform a wheel alignment. So we can maybe do a webcast on that one day or something. Other areas, is there only a simulator for all? Is there a simulator for all areas? So all Electude lessons have some form of simulation in them. As far as the intricacy of this simulator and everything that you can do, the parts replacement, this is fairly advanced, and it's really very unique to this to engine management. Although there is a good number of electrical faults that you could use, like with the cooling fan, with these relays, etc., in your electrical courses. I will direct you also to the new case study modules that are coming out. Maybe that's a good opportunity to show you that. So if we go over here to courses, case study, here's the first one that was released, and this is diagnosing a hybrid system. You're going to see some familiar tools here, like the scan tool and things like that. There is a work order and things like that, but they're going to be asked questions along the way. So it's going to be kind of leading them through a little bit of a diagnostic process. But then here's your real world wiring diagram. So this is, from a real vehicle. It's not just from this, looks like a Toyota wiring diagram of some sort. But they're going to be asked questions and things like that as they go. And then they have a lab scope and a breakout box, and they got their wiring diagram, and they can then make decisions based on what they measure here in this wiring diagram together with the lab scope. So you're going to see elements of that simulator, but used a little bit differently in these case study modules. I'm told that through the progression of time, these are going to be over electrical, engine performance, and then air conditioning electrical faults. There's also going to be some faults using this lab scope where they're going to diagnose certain electrical faults with the air conditioning system.
Yeah,
So,
Darcy, can I just add, I know also there's going to be an emphasis on OBD in this, and it's going to be diesel and gas engines with cases included.
okay, very good. And as far as some of the other areas, I'll just show you for those of you that are fairly new to Electude. I'm just going to show you like in the air conditioning area. The leak detection. UV. I'm just going to search for UV. There we go. So this lesson here is I would consider this to be pretty high level simulation. So they're going to be learning here about, refrigerant dyes and things like that. So as they go through this, eventually they get to turn on the black light for themselves and get the glasses out and search for a leak. So here again, not maybe as advanced as the engine management simulator, but a simulation nonetheless. So there's the ability to virtually check for leaks and things like that. The electrical area, a lot of good. Another good lesson is fault finding. This is a fantastic simulation here where they have to, they're going to be learning the basics of how to do a voltage drop and things like that. But then here toward the end, this is actually one of the heavy vehicle ones. That's why it's got 2 batteries. They have to diagnose this mirror defroster circuit. So they've got a real simulation here where they can turn this thing on. Doesn't look like it's powering up at all. There we go. It powers up, and they can do their their voltage tests and things like that. Basically, do a virtual diagnosis on a mirror circuit. Notice that it is 24 volt. The heavy vehicles in Europe are all 24 volt systems, so all the heavy vehicle electrical faults are 24 volt. Just FYI there. If you're wanting to provide a 12 volt version of this, then look for the fault finding lesson that belongs to Automotive Essentials. So this one here, this is the auto one. And now you can test the 12 volt system. So same lesson, but one is going to be 12 volt for light vehicle, 24 volt for heavy vehicle. So here again, very, very nice simulation. Moving on with the questions. This would really help for going back in a virtual type mode. Absolutely. These, even this lesson here, if you're teaching virtually and you want to push this text off the screen, we got this little button up here, the presenter view, and now you've got a nice working, you can manipulate this, and now you can work with your students on a without the text being on the screen, and go through a diagnostic fault scenario with your students. So here again, this would be perfect for using this in like a Zoom environment or something like that. Let's see, second, a simulation on steering suspension alignment. Yeah, let me show you that one really quick. That would be wheel alignment. So if we go here to modules, this search feature works fairly well. You could also find it in the courses, but alignment report and adjustment, that's the one I'm thinking of. Here we go. So they basically have to, they're going to be led through adjusting caster camber toe, looking at the front and rear axle, the specs and so forth. I'm kind of skipping around here a little bit, but just like on a real car, if you adjust the toe first and you get that perfect in the green, whatever it should be, I'm just going to set it to 0 here. And then if you adjust the camber next, look what that does to the toe. Just like a real car, it's going to throw the toe off if you adjust it first. So you always want to adjust your camber and then set your toe last. So so it's a very nice simulation where you can adjust each wheel, front and rear. But yeah, they can make adjustments. So it's not physically grabbing the wheel or turning the wrench, but as far as learning the thought process and what you have to adjust first, and starting with the rear and then moving to the front, etc. It's a fairly nice simulation in the steering suspension area. I would say every area has some really nice animations. In transmission transaxle, there is one where they have to virtually replace a clutch. Here it's easier for me just to probably go to the course. Go to courses, AST mast. We'll go into manual transmission, clutch theory. Here, clutch disc maintenance. That's the one I was trying to pull up. I skip all the way to the end here. They have to basically go through a virtual clutch replacement. Find the right place here. Click on the drive shaft to remove it. So remove the drive shaft. Answer some questions on the way. Click on the transmission to remove it. So here again, some really nice little animations here. They gotta, remove the bolts and things like that as they go through here and they start to put the clutch back together. They have to do things in the right order, and they have to use a centering tool and things like that. So here's our centering tool. Of course, I'm not doing things in the right order here myself, but you kind of get the idea. You put your bolts in and things like that. So here again, a very nice simulation where you can practice, not meant to replace hands-on, but to simulate thought processes and things like that. Can we set up generic class with faults and case scenarios and copy those courses to next semester for our to meet our needs? Absolutely. You can build your own courses in Electude. So if I go here to courses, self-made, and I want to build a new course called engine. Let's call this Darcy's engine simulator faults. So there's my course, doesn't have anything in it. So yes, you can then go to, once you get your course up here, go to modules, ASE content areas, Electude simulator. You can also, explore these folders, or you can use this module filter. Another thing you can do is configure your filter to only look for simulations when it's on. So I can go to modules, all new. So here's about 1 million things you can see there. But if I flip my filter on, the only thing we're going to see is simulation faults. So now I'm just looking at an exhaustive list of all the simulator faults without having to mess with those folders. Here's all the ones that I've kind of already pre-built. So I can then, here's my course up here. Here's my pre-built simulator faults, and I can, here's a custom fault. I'll throw that in my course. This one here, this one, whatever you want in your course. And so you put all your faults in there, and then yes, this course then is removed. You can assign this then to your students semester after semester after semester. So if I go over here to students, here's my demo class. I can remove these modules. So here's my empty class. Now I'm going to assign the course. So now they got Darcy's engine simulator faults, and when they open that folder up, this is all they're going to see. So that's how I would actually recommend you use the simulator, is build your faults out first, and then create a self-made course, and then take your self-made course and put the faults into it, and then you can reuse this every semester. So I know we've gone over on time. I could probably spend another 2 or 3 hours on this simulator, to be honest with you. There's a lot to learn, and we can do additional maybe trainings on this again and again. But this at least hopefully gets you started on your way using the simulator. There's also a lot of good YouTube videos on this that you can review. Remember, when you have the simulator open, there are those video tutorials that you can read and watch. But hopefully this will get you started at least on down the right path. And if you have questions as you're going, navigating through your trial, or you're a new customer, reach out to your sales rep for questions. If your sales rep doesn't know the answer, they can reach out to myself or our support person, and we can get you the answers you need. I'll just pause here once more to see if there's any last questions.
Darcy, if I may, Darcy,
yeah, please.
I just want to advertise our next webinar. So Thursday morning at 9 o'clock, we're going to have 9 o'clock Eastern time. I'm sorry, we're going to have a webinar on Canvas. So when Canvas is integrated with Electude, we have our integration specialist coming. He'll walk through the basics of getting things set up and field any question. We have quite a few people signed up. If any of you are working at a school where Canvas is used across campus and you are interested in integrating Electude into Canvas, feel free to attend. As I said, 9 o'clock Thursday, and if you go to electude.com, you'll find the sign up just like for this one. We do have a live support session Thursday at 5, so people can just call and ask pretty much anything. And then Friday in the afternoon at 5 o'clock, we have another one of our student management webinars. So that's a webinar where we talk about just the basics of getting students into the system and assigned into courses and having content assigned to them, and how you do basic assessment. And that's going to be actually presented by one of our customers who does a beautiful job. The last one last week was excellent, and I'm looking forward to it. If you're new to Electude and you want to learn some of the basics of student management, I highly recommend. And you can look through the rest of our schedule. We have quite a few more coming, and we'll be adding more as we go. So please feel free to sign up. Thanks, Darcy.
Yeah, all right. Well, I think that's probably all the time we have for today. So thank you so much for attending and all the great questions. If we didn't get to all your questions today, you're welcome to send your comments to the support, our support email. So if you click on support, teacher support, you're welcome to send us an email. We also got all these videos and things here as well. But please reach out to us. Ask if you had a question that wasn't answered today. We'll do our best to answer those. So thanks again for attending. But that's be all for now. So we'll see you here again real soon in our next webinar.